Let's talk about the inverse trigonometric functions. So the inverse trigonometric functions you can think of as undoing the trigonometric functions. In other words, when you plug in something into, say, the inverse sine, what you're saying is, what angle gives me this value? So that's what arc sine, arc cosine, and arc tangent are. These are just the same, these are different terms for the same thing. Inverse tangent, arc tangent, inverse cosine, arc cosine, inverse sine, arc sine. You might see either one of those notations, so you should just be aware of that. The thing you might think about, though, is that we know that there are multiple angles that have the same, say, sine value or cosine value. And because of that, we need to limit ourselves to a specific range of values so that the inverse sine can be defined as a function, right? We can't allow multiple values for a function. So the way we do that is we take a specific ranges for each of these functions. The thing to think about with sine is that as sine goes from minus pi over 2 to pi over 2, it hits all of its values. It hits everything from minus 1 all the way up to 1. Remember, sine is the y value on the unit circle, so from minus pi over 2 to pi over 2, sine hits all of its values. So that will become the range for arc sine, for inverse sine. Similarly for cosine, cosine, remember, is the x value on the unit circle, and so cosine hits all of its values as cosine goes from 0 to pi. It hits everything from 1 to minus 1. So that will be the range for inverse cosine. We won't allow any angles other than the ones from 0 to pi. And now tangent hits all of its values going from minus pi over 2 to pi over 2. You can imagine that when you're close to minus pi over 2, tangent is very close to minus infinity. It's a very small, very big negative number. And then as tangent increases, as the angle increases up to 0, that's where tangent is 0. And then as the angle increases up to pi over 2, tangent gets close to infinity. It gets very, very big because, again, tangent is y over x, and y is big relative to x as you get close to the axis. So from minus pi over 2 to pi over 2, tangent hits all of its values, so that will be the range for arc tangent, for inverse tangent. So let's just look at this. This just summarizes what I was just saying, that the range for arc sine will be minus pi over 2 to pi over 2. The domain will be minus 1 to 1, because those are the possible values of sine. The range for arc cosine is 0 to pi. The domain is minus 1 to 1, again, because the only possible values you can get from cosine are minus 1 to 1. And remember, because tangent has all sorts of outputs, its domain will be minus infinity to infinity, and its range will be minus pi over 2 to pi over 2. So again, whenever we take an inverse function, what we're saying is what angle in this particular range has that value of sine. So let's look at some examples. Suppose we're asked to compute inverse sine of minus a half. So we can know this from the unit circle. One thing that I just like to draw myself a little unit circle to remind myself what I'm doing. Inverse sine of minus a half. I'm looking for an angle which has a sine of minus a half. So minus a half looks like this on the unit circle. So which of these do I want to take? There's a lot of ways I could express these angles, but remember, because inverse sine is going to be between minus pi over 2 to pi over 2, I want an angle that is between minus pi over 2 and pi over 2. That's going to be this angle, which is minus pi over 6, or minus 30 degrees. So minus pi over 6. That's going to be the angle between minus pi over 2 and pi over 2 that has a sine value of minus a half. Okay, let's look at inverse cosine of minus the square root of 3 over 2. So again, I like to just draw myself a little unit circle to remind myself how this goes. So inverse cosine of minus the square root of 3 over 2, I'm looking for an angle which has a cosine value of minus the square root of 3 over 2. That's going to look like angles over here. Those are the angles that have a cosine of minus the square root of 3 over 2. But remember, because inverse cosine has a range of 0 to pi, those are the angles that I'm interested in. So that means I'm interested in this top guy here, this angle here, which is an angle of 5 pi over 6, just short of a full pi. So this is 5 pi over 6. Let's look at a few more. Okay, I'm looking for inverse tangent of the square root of 3. So remember, again, I like to just draw myself a little diagram. So where will tangent equal the square root of 3? Well, that's going to be at an angle where the y value is bigger relative to the x value, and that happens to be over here at pi over 3. That's going to be the angle here. It also happens over in the third quadrant where both sine and cosine are negative. But remember, tangent is only from minus pi over 2 to pi over 2. So we're going to be up here at pi over 3. So that's what inverse tangent of the square root of 3 is pi over 3. And now what about inverse sine of the square root of 2 over 2? Well, sine is equal to the square root of 2 over 2 at these 45-degree or pi over 4 angles in the first and second quadrant. But because sine, inverse sine, has a range of minus pi over 2 to pi over 2, we want the one in the first quadrant. So we want pi over 4. That will be the angle which has a sine of the square root of 2 over 2 that's in that correct range. All right, what about inverse tangent of minus 1? Well, tangent is equal to minus 1 in the third quadrant, the second quadrant over here, where sine and cosine have the same absolute value but are opposites in signs, and also over here in the fourth quadrant. But remember, tangent has a range from minus pi over 2 to pi over 2, and so we want this angle down here in the fourth quadrant, and we want it to be minus pi over 4. Alright, what about inverse sine of the square root of 3 over 2? Well, remember, sine is equal to the square root of 3 over 2 up here in the first and second quadrants with those bigger angles, those pi over 3 angles. But again, we are only interested in minus pi over 2 to pi over 2 when we're dealing with sine. So we're going to want this angle here, this pi over 3 angle. Alright, to finish up, what about inverse cosine of 0? So let's think about that. So cosine is equal to 0 on the y-axis, but because cosine has a range of, inverse cosine has a range of 0 to pi, we're going to want this top one, and that's going to be at pi over 2. Alright, finally, what about inverse cosine of minus 1? Well, cosine is equal to minus 1 over here at pi, and that's within the range, right? 0 to pi. So this will just equal pi.